So today we are finding zeros by factoring when a is greater than 1. So we already found zeros by factoring, and we just found two numbers that multiplied to the last, added to the middle. Today is the day where we are going to use the style of factoring that we learned how to do in 5.9. So a recap of what we did back in 5.9. We found the two numbers that multiplied together to AC and added to B. We used this big X for that. Then we split up our middle terms. We factored by grouping, which we have our steps of factoring by grouping there. And then the new part of this, since we've done it in 5.9, just like how when we factored in 6.4 and we set them equal to 0 and solve, we're going to set each of our factors equal to 0 and solve them out. So we've got an example here. We're going to go through at kind of a medium pace because we would love if you guys could do this, but we have another option as well. So pay attention to this, pay attention to your notes, and then you can decide which option you prefer. So we've got f of x equals 2x squared plus 17x plus 21. My a value is 2. My b value is 17. My c value is 21. I'm going to multiply together a times c. So that's going to be 2 times 21. It's going to be 42. So I'm multiplying together my a and c value. Okay. We need to find two numbers that multiply together to be 42, and they need to add together to be 17. I would like everyone to know that when I was making these, or I already had these notes made, when I was making the key for them this year, I stared at this for a long time. Does anybody know what they are? Because the only thing I can think of that went into 42 is 7.
1, 2, 3, 6, 7, 14, 21.
It's the 14. So it's 14 and 3 add up to 17. So 3 plus 14 add up to 17. If you are stuck, I would do what Jasper just did. Make yourself a list. Well, Jasper Googled it. That's fine. Use the multiplication table in your notebook. Make yourself a list of all of the factors of 42 and see which ones add up. So 3 and 14 add up. Okay, from there, that's step 1. Find the two numbers that multiply to AC and add to B. We then use those numbers to split up this middle term. So instead of having plus 17x, we're going to have plus 3x plus 14x. I still have my 2x squared. I still have my 21. Okay, 2x squared plus 3x. We cannot divide 2 and 3 by anything, but we can pull out an x. So I'm going to pull out x out of these first two terms. 2x squared, pull out an x. Use behind the 2 and the other x. 3x, pull out an x. Leaves behind the 3. (14x) and 21. We can divide 14 and 21 both by 7. We'll divide a 7 out. 14 divided by 7 is 2, and we still have that x. 21 divided by 7 is 3. So we've got this 2x plus 3. These match up, which is what we want. That's going to be one of my terms. And then this x plus 7 makes up the other. Okay. Any questions right now? Okay. So this is going to be one of your two options of how to do your assignment today. We've got to finish this up to find our zeros. So if you choose to use this option, we're setting this equal to 0. And so in order to find out when this entire thing equals 0, it would be when either this equals 0 or this equals 0. So zero product power, zero product property, something like that. We're going to take this 2x plus 3. I'm just going to do it over here on the side. Set it equal to 0 and solve like a normal equation. We're going to end up with a fraction on some of these. So I'm going to subtract 3 from both sides. We'll get 2x equals negative 3. And then we'll divide both sides by 2. We'll get x equals negative 3/2. And so we'll leave it as a fraction, negative 3/2. That's one of our answers. For our other one, we will take this x plus 7, set it equal to 0. And this is just one step to solve. We'll just subtract 7. We'll get that x equals negative 7. Okay. What this means is that if I were to plug in negative 3/2 or negative 7 in for this equation, I would get 0. Do that real quick. I just think understanding that that's how you would check it is cool. So 2 times negative 3/2 plus 17 times negative 3/2 plus 21. I got 0. I can do the same thing. Plug in a negative 7. Plug in a negative 7. I also get 0. So those are the two numbers that we can plug in for x to get 0. Okay, any questions right now? All right, flip this over then. We've got one more example on the back. We're going to do the example on the back twice. So, we've got a little note up here. In order to find the zeros of a quadratic when a is greater than 1, we have two options, like I was saying. We can factor, like we just did, or we can use the quadratic formula. So the quadratic formula is what we did in 6.6. So we are going to do this as the last example both ways so you guys can see getting the same answers both ways. Then when it comes to your assignment, when it comes to your, we're going to have to use this tomorrow when we're graphing. So your assignment today, your assignment tomorrow, when it comes to your review and your test, you can pick the method you prefer. A lot of people prefer to factor, but then if they can't figure out what the factors are, they like to plug it into the quadratic formula. If I were you on my test and I was concerned, I would do it both ways and use it to check my answer. Okay, so we're going to start with the factoring method. We've got 3x squared minus 8x plus 4. Let's label our A, B, and C. We are looking for two numbers. We need to multiply together A times C. So A times C is 3 times 4, which is 12. So we are looking for two numbers that multiply together to be 12. and they need to add together to be -8. What multiplies to 12 adds to be -8? -6 and -2. And let's go ahead and do them in that order. It doesn't matter what order you do them in. You can do -2 and -6 or -6 and -2. It's gonna change a little bit of how your work looks, but it's not gonna change your final answer. So we're gonna take this original equation. I'm just gonna go ahead and write it down. 3x squared minus 8x plus 4. We're gonna split up that minus 8x into minus 6x minus 2x. We are intentionally uncombining like terms. And then we still have our 3x squared. We still have our plus 4. Okay, out of that 3x squared minus 6x, we can divide a 3 out and also an x. So we can divide a 3x out. 3x squared divided by 3x is just x. Negative 6x divided by 3x is -2. Out of -2x plus 4, I can divide 2 and 4 both by a 2, but anytime my third term is negative, I want to divide out a negative. So I'm going to divide out -2. So -2x divided by -2 is just x. 4 divided by -2 is -2. So that leaves me my final answer. My pieces that match are x minus 2. And then my GCF and my GCF is 3x minus 2. Okay. Any questions thus far? Okay, we would set each of these equal to 0. X minus 2 equals 0 when x equals positive 2. So that's one of my zeros. And 3x minus 2 equals 0. For this one, I don't have space here, and I want you guys to start seeing the pattern. We would add 2 to both sides and then divide by 3. So if this is subtraction, we would add. If this was addition, we would subtract. So that determines whether it's going to be positive or negative. And then we divide by whatever number's in front of x. So this is going to be 2/3. It's going to be our other 0. So we've got 2 and 2/3, but not 2 and 2/3. Separate. All right. Any questions right now? Okay. If 5.9 went straight over your head, and then these two examples went straight over your head, we would love for you to come in and get the help that you need to be able to understand factoring in this method. But we do have another option you can use to get by in Algebra 1. This, what we just did, is something that you will need to know how to do in Algebra 2. In Algebra 1, we have a workaround that we're going to let you guys use. And that is using the quadratic formula instead. So we can take the exact same problem, instead of factoring it out, setting our factors equal to 0 and solving, we can use the quadratic formula. We're going to do an example like this, and then you guys can decide which one you prefer. So we've got our quadratic formula up here. X equals -b. So negative b is going to be -8, so that's +8, plus or minus the whole big long square root of b squared, which is -8, squared, minus 4 times my a value is 3 times my c value is 4. And then make that a big long fraction over 2a, which is 2 times 3. Okay. So, first step after we plugging things in is the first step. Next step, do that discriminant. So everything underneath the square root. So -8 squared minus 4 times 3 times 4. And I get 16. So now I have 8 plus or minus the square root of 16 over, we go ahead and do 2 times 3, it's 6. And then I can do the square root of 16. The square root of 16 is 4. So I get 8 plus or minus 4 over 6. And then I would need to split and work on finding 2 answers. So I split this fraction. It's going to be 8 plus 4 over 6 and 8 minus 4 over 6. Eight plus 4 is 12. 12 divided by 6 is 2. Eight minus 4 is 4. And then 4 over 6 can be reduced. We can divide the top and bottom both by 2, and we get 2/3, which are the answers we already have written down. Fancy. Okay, so we've got only about 17 minutes left. I would like for you guys to get started, and then we will give you guys some work time tomorrow and Thursday to continue working on these. So you have your choice. You can factor, you can do the quadratic formula. It doesn't matter to us. What does matter is that you choose one and figure it out. We don't want you to do an okay job of 2. We want you to do a good job of 1. Okay. And if you don't already have quadratic formula down, I would focus on that one because we have to be able to do that anyway.